Alright, Advent Code, Day 5, Binary Boarding. You board your plane only to discover a new problem. You dropped your boarding pass. You aren't sure which seat is yours, and all of the flight attendants are busy with the flood of people that suddenly made it through passport control. You write a quick program to use your phone's camera to scan all the nearby boarding passes. Perhaps you can find your seat through the process of elimination. Instead of zones or groups, this airline uses binary space partitioning to seat people. A seat might be identified like FB, FBB, where F means front, B means back, L means left, and R means right. I don't quite parse that, but the first 7 characters will be F or B. These specify exactly one of the 128 rows on the plane. Each letter tells you which half of a region the given seat is in. This would be the front of the plane and the back. So F means to take the lower half, keeping rows 0 through 63. B means to take the upper half, keeping rows 32 through 63. This basically is this a process of elimination, essentially? So you have the whole range. We're taking out these rows if F is here. The final F keeps the lower of the 2, row 44. Okay, so we're essentially just applying a filter to this. The last 3 characters will be either L or R. These specify exactly one of the 8 columns of seats on the plane. So I'm still kind of parsing this out. This almost looks like this is a binary search, essentially. Yeah, binary boarding. So you're just taking this array of characters and then you're taking an array essentially of 127 seats and then you're doing a binary search on it. So you're either keeping the upper or the lower half, right? So and then you're filtering that down into 1 based on what this input is. What is this LR though? L means left and R means right. So I guess we don't really, do we care about this LR? Oh, the last of the 3 characters would be either L or R. These specify exactly one of the 8 columns of seats on the plane, numbered 0 through 7. The same process as above proceeds again, this time with only 3 steps. L means to keep lower half, R means to keep the upper half. Just consider the last 3 characters of this, R, L, R. Start by considering the whole range. R means to take the upper half, keeping 4 through 7. L means to take the lower half, 4 through 5. The final R keeps the upper of the 2, column 5. So decoding this reveals that it's seat 4, column 5. So we essentially are doing the same process, but with different inputs. As a sanity check, look through your list of boarding passes. What is the highest seat ID on a boarding pass? Here are some other boarding passes. So this is what we can use for test input. Seat ID 567. So the seat ID, the unique seat ID is where you multiply the row by 8 and then you add the column. So in this example, this is 44 times 8 plus 5 because we're multiplying this by 8, 357. Okay, so I'm going to start by writing test for this. Day 5. And then what does our input look like? It's basically just these. Okay, just a list of these. So what I'm going to do is just copy this, and then we can use this as our test input. Create a file, day5.txt. So now I'm first going to, these are all going to be the same. So it's going to be the first 7 characters are either front or back. So I'm going to start off by just seeing if I can parse that out and run through this range here. So what I'm going to do first is just parse this input here. Day 5. Copy this read input, or read lines here. Just going to call this boarding test for now. I'm actually just going to start with 1 here, just this first one. Okay. And I'm just going to start with like a kind of a quick and dirty brute force solution to this. It's probably not the right way to go, but I usually start with a brute force solution and then make it more efficient or just improve it over time. So we have these characters. So what I'm going to do is first get the first 7. I'm going to substring this 0 through 7. Row equals this. What would be cool is if I could have a mapping of, or some kind of a tree. Okay. So row dot for each. And then I'm gonna make a list of this range of 0 through 127, right? And And then Kotlin has this range operator. I think that this is inclusive. Or no, this is not. Until I think it's until 127. Is it exclusive? Excluding it. I don't want that. I want this to be inclusive, and I think that's what this does. Range 2 creates a range from this value to the specified value. What I do notice is that this is (128) is 2 to the 5th, right? Or no, 2 to the 6th. Nope, 2 to the 7th. There we go. So this could be represented as some kind of binary, just to put a pin in that, like this. I'm sure there's some way to represent this as bits, right? So it's 2 to the 7th, and then this is 7 here. So I almost wonder, like, is there a way to just encode this as a binary? So the row here would be 70, right? So what if we treat I'm just curious, like, what if we treat the b's as zeros? B means to take the upper half, keeping rows 0 through 63. I almost wonder, like, what if a B is a 1 and an F is 0? Let's try that. I'm lazy right now, but this would be row 70. Okay, so this is already not correct because this is the 1 in the 7th position, so this would be 127 or 128, right? So what if we invert this? One, two, three, four, five, six, 7. Seven. Didn't quite work. Oh well. I'm sure there's a way to do this using binary, but I just woke up and I'm not running at full steam right now. So yeah, basically we just need to do a binary search here. I'm going to make this a .toMutable list. And then I'm just going to go through this row, and then I can just keep splitting this list, right? So row.forEach. if so here's the character. If it is an F, then I think I need to use single quotes here. If it's F, then we want to take the lower half. So we want to basically take the floor of this, divide 127 by 2, and take the floor. I'm going to make an else here. Let's see, how do I remove, I need to remove this that sub list? Okay, yeah. I'm going to make this a var. I don't like introducing mutability, but it is what it is. And in this case, this doesn't have to be a mutable list, but I will make this a list. Because it doesn't have to be a mutable list because I'm going to reassign it. So I'm going to have seats equals, because Kotlin can return a value from an if statement. I'm going to say seats.sublist. If it is F, then I want to keep the lower half, right? So this is going to be 0 through the floor. I wish that I could I'm going to do I think I'm okay just doing seats.length, seats.size divided by 2. I think it'll round down by default, so 127 divided by 2. I think, yeah, integer division rounds down, I think. Otherwise, we want to keep this 0 to 63. B means take the upper half. So this would be, we want 64 through the end. So I'm going to do this. I'm just going to do +1. And then seats.size. And then what we want to do is just, I'm just going to print ln seats just to check that the only, so in this case, like we're doing a process of elimination here, and the only seat left should be this row 70. I'm actually going to change this to rows, and then I'm going to say assigned row. Or this is actually going to be boarding pass. There we go. Okay, so let's try this. Hopefully we don't blow up or get some kind of index out of bound. I'm a little concerned about this math here. Okay, so rows has nothing. It has exactly nothing in it. So we messed up somewhere. Let's just step through this real quick. And I don't, is this guaranteed to run in order? Perform the given action on each character. Looks like the contract of this isn't really clear that it runs in order. I think that's a safe bet. So, all right. So I want to see what rows looks like after each pass through this list. So we start off 128, which that's already not correct, I think. Right? We only want zero. No, that's okay, because 0 through 127 is going to be 128 rows. Okay, that's okay. Yeah, so we're good. So after this first pass, this B means to take the upper half, or actually, so F means to take the lower half, 0 through 63. So in this case, we want rows to be 63 through 127, and I can already see that this is not correct. So this is showing 65 through. So I think it's a mistake to add this one here. So we want to do a sublist of these. Let's take a look at this. Okay, so rows now is 64. Okay, yep. 64 through 127, that's what we want. And then I'm going to just do this. I'm going to take their example here that they gave us, because they walked us through the algorithm. So I can see what this should look like for each step. So we want 0 through 63 this first time through. Zero through 63, yep. And then 32 through 63. Yep. And then we want 32 through 47, yep. And then we want 40 through 47, yep. And 44 through 47, and then F means 44 through 45. Okay. So now we end up with these rows that's a size of 1, and we end up with 44. Cool, we got it. I think I'm going to start factoring this into a boarding pass class. That rhymed. I'm proud of that. I'm going to make this boarding pass. I'm going to make a private val. What do I call this? I'm going to call this the seat. No, I'm not going to call it the seat. I'm going to just call it the input. I don't know. I'm going to call it boarding pass string. And it's a string. Okay. And now I'm going to factor this into, this is going to be get my row. I'm just going to call this row directive. I don't like my variable names this morning, but I'm going to deal with them later. So we're going to take this boarding pass string, blow it up into a substring, and then we just want to return, this is going to be an int for the row. And then we're going to return rows dot just the first one, right? Or 0. So we're going to return this first row. So real quick, I'm going to write a test that handles this input because we know the rows here. I think what I'm going to do is make this, no, that's okay. I'm just going to keep this. I was thinking of factoring this into a separate, yeah, I'm just going to leave it. It does generate that range every time, but whatever. What we want to do is read lines from this day5.txt. You know what? I actually am just gonna do this. I'm just gonna copy these inputs here. I'm just gonna make this into a boarding pass. And I'm gonna make a private fun test rows, and this is gonna be boarding pass string, and then I'm gonna have an int for the expected rows. And then what this is going to do is take this string and then create a boarding pass out of it. So we're going to pass in this boarding pass string, and then dot get row should be expected row. And this is going to be a singular. And then I can just pass in this string here, test rows. This one they're telling us that it's supposed to be 70. Make copies of this. This is supposed to be 14. And then this other one is supposed to be 102. Now let's try it. Let's make sure that we did this correctly. Cool, so these all check out. So now we need to parse these columns. And this is going to be the same deal where we're just going to take this sublist of it, or this substring. This is also going to be an int. And you know, this is bad practice, but I'm just gonna copy this. I'll refactor it later. I'm gonna make this columns, and then this is gonna be 0 through 8 is what we want. This will be the column directive. I'm actually going to call this assigned row. then this is essentially this seat, right? Assigned seat. Then we want a substring. We want basically 7 through. It's going to be a first 7 characters. And then we want character 8 through, so this is is it 7 through 9? But it's 0 index, so is it? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, yeah, so this will give us the correct substring. So then we want to, if basically this lower character is the equivalent of B, so R means to take the upper half, L means to take the lower half. Okay. Make another method called test columns, and then expected column. So I'm doing something similar to what I just did with the rows, and I'm just parsing this through. Test column, so what it tells us here is that this one is supposed to be column 7. I'm going to swap this with test columns. Expected column is 7, row is 14, and then there's column is 7, and then this is column 4. Okay, run this through. I'm not expecting this to work on the first time through. Sure enough, it doesn't. It's expected 7 but was 6, so let's run through. I think what I'm going to do first is just take this string that they gave us, and then walk through just like I did before with these steps and what the values should be. This one, we expect the column would be 5. And I'm going to step through this. So what it tells us is this R, we want, first of all, we're hoping for this assigned seat with 3 characters, and here's the problem. We only have 2 characters, so this substring is not correct. We're not quite getting the last bit of it. I think I always run into this. Is substring, this is exclusive, that's why. So we do need to make this 10, and that should give us the full string. So RLR, okay, that's correct. And then let's just step through this. Actually, did this pass? Yeah, okay, so our math checks out. We're good. And now we just need to make a get seed ID. And Kotlin actually has a val column. Kotlin, you can call these, you can create a getter around this so that you can actually call this method as a parameter or as a property on the class. So if I do this, I can just say get is this. So now I should just be able to, I'm just going to do a test real quick. This is just some kind of light cleanup of this code here. So I should be able to just call this as a property. And now if I run this test columns method, it should handle it the same way. I kind of like using that parameter syntax. So I'm going to cut it over here. So I'm going to make this row. Row is an int. And then get, and then it will define that method here. And I'm also going to do the same thing with seat ID. It's an int, and then the getter is here. And we're going to get the row, get the column, you get the row and multiply by 8. Row times 8. Row times 8 plus column. A separate method for testing the seed ID. Test seed ID should be expected ID. $357 is the first one. 119. 820. Did I miss something? 5. This one. Oops. I am very not awake yet. 357. 567. 119 and 820. Okay, and now what they want us to do is look through this boarding pass list and find out what the highest seed ID is. So we're essentially going to, I'm going to call this I'm just going to call this day 5 -part1.txt. Paste in our input. read these lines. Day 5, part 1. Come on. Did I lose my cursor again? I just upgraded IntelliJ and this new version's kind of buggy. Sometimes. It looks like it's just locked up. What's going on? I don't know. But I think it's saved, so I'm just going to kill IntelliJ real quick. It's really annoying. Force quit here. Okay, we are back online and read these lines. Day 5. And then we're going to map these into boarding passes. And we want to get the max by... Come on. And then we're going to use a selector for this dot get ID, seat ID. And then we'll just print this, print ln max ID. See what we get. Didn't give us any output. What is this supposed to give us here? Returns the first element yielding the largest value of the given function, or null if there are no elements. That should be it. Is this really null? Oh, hang on. Oh, it is giving me the boarding pass. I see. So it's not actually giving me the... what I want to do is actually... I'm just going to map these into seat IDs and then just get the max. So what it was doing was giving me the boarding pass. It was giving me the ID, or it was giving me the boarding pass that had the highest ID. Why does max not work? This is deprecated. Oh, max or null instead. Okay, so that's fine. We'll just do max or null. And then this max ID now should be just this int of seat ID. So 935 is the highest one. Does that check out? I mean, just doing a quick once over of these, it is higher than all of these. Let's try it. We got it. So part 2. Fasten seatbelt. Signs have been turned on. Time to find your seat. It's completely full flights. Your seat should be the only missing boarding pass in your list. However, there's a catch. Some of the seats at the very front and the back don't exist on this aircraft, so they'll be missing from your list as well. Your seat wasn't at the very front or back, though. The seats with IDs 1, +1, and -1 of yours will be in the list. Okay. What is the ID of your seat? Okay, I need to think about this for a minute. I'm going to rename this to day 5 full. So essentially what it's telling us is that we can rule out seats that were in the very front or the very back. So we're looking for something in the middle, some missing IDs with +1 and -1. This is actually kind of nice that it gives us this normalized seat ID, because then we can run through these numbers and see what's missing. We could find some gaps in these. The thing is, how do we find those gaps? I think what I'm going to do is just get an array of these. I'm going to start off with that. Val, I'm going to call these IDs, and then println IDs. Let's just take a look at this. What do these look like? I'm going to sort these. So that's another thing, is these are all going to be out of order. So we want to start by sorting them. And we can see that there's, yeah, so this starts at 63, 4, 5, 6, 7. Yeah, so what we want to do is just search for gaps in the middle of this list. So I think we could probably do a process of elimination and just see what you could do a set intersection. So you could have like a set of We could have a set containing the lowest and the highest range of these IDs, and then just do a set. Yeah, just do set subtraction. That should be pretty straightforward. So I'm gonna take IDs.toSet. I'm actually first I'm gonna go IDs dot these are sorted. Min or null. No, I want just min or null. Okay, I'm gonna make a new range here. And I know this is not going to be null. So this is going to be my new range.toSet. So this is going to be a val called full seats. Or so I'm going to just call it seat set equals this. So we just want to take this set of seats and do a set subtraction. I think I can just do minus elements, and then I'm going to do IDs.toSet. So we're taking the full set of possible seats, and then we're subtracting off this set of IDs. And then that should leave us with 3 seats. That's what they're telling us. The ones with +1 and -1 from yours will be in the list. And we want to find the midpoint of this. I just want to make sure that this is correct. Like what I'm expecting is that for this to return 3 seats, and then we just find the middle of those. Okay. Oh, okay, so it does give us the one remaining one. Okay, that's fine. That's even easier. So the one remaining one is 743. Oh, okay, so seats with IDs +1 and -1 will be in your list. So they weren't actually saying that those are missing too. So submit, that's the right answer. Okay, cool. Alright, that was a fun one. I like that. I'll probably do some cleanup and refactoring and stuff on this boarding pass if I have a spare couple seconds in the day. I think that we could probably pull this binary search logic into its own method that's just a private method, and then we pass in what we want the upper and lower bounds to be. But not a big deal. It's not that much duplication of code. But anyway, thanks for watching, and I'll see you next time.